We're back. We're back to talk about one common issue with denominators, uh, other than the ones we've talked about so far, which is deciding whether to use an absolute or a relative difference. So, first of all, let's talk about what absolute and relative numbers might mean. So, an absolute number could just be something like 20 or 500. Relative numbers come in two main flavors: proportions, or how much of a whole is some number. So, for example, if you have 500 cases out of 1,000 people, then 50% is your proportion. You can also have a ratio, which is broader any comparison of two numbers. For example, 1,000 divided by 500 can be expressed as 2 or 2 to 1. Now, what about absolute versus relative differences? Let's say we have an exposed group that has some outcome, like death from heart disease, 20% of the time, and the unexposed group experiences that outcome 10% of the time. We could express this difference in a couple of ways. One is to calculate an absolute difference measure, like 20 out of 100 people who were exposed had died from heart disease, and only 10 out of 100 who were unexposed died from heart disease. We subtract those two from one another, and we get an absolute difference of 10%. 20% minus 10% is 10%. Or we can look at a relative difference. We can take the 20% in our exposed group, divide it by the 10% in our unexposed group, and get 2.0. But let's say our exposed group, instead of looking at death from heart disease, we look at death from lung cancer. So in our exposed group, that happens 2% of the time, and in the unexposed group, 1% of the time. Our absolute difference is now 1% instead of 10%, but our relative difference is still 2.0. It still represents a doubling of risk in the exposed group. So my point here is that relative differences can be used to make tiny things seem big, or absolute differences can be used to make pretty big things seem tiny. And which one is more appropriate requires careful thought and consideration on a case-by-case basis. Okay. Now, why am I putting absolute versus relative differences in the denominators lecture? Well, let me try and shoehorn it in here a little bit. In a relative difference, our denominator is the risk in our unexposed or untreated group. But in an absolute difference, our denominator is the total units in each group, or you can think of it more broadly as some arbitrary number of units that might be treated. Okay, so two different denominators, I think, lead us to use absolute or relative differences. Let's go to a drag queen now, dissecting misleading headlines about medical studies on TikTok. Why not, right?
Of the time that misleading statistics led to a 9% rise in abortions in the UK. It all started with a headline that read that women who were using a particular birth control pill were twice as likely to develop blood clots. Now, as you know, most people don't bother to read the footnote that goes along with the headline, which is the article itself, because what the researchers actually found was that the risk of these blood clots went from 15 in 100,000 to 25 in 100,000 from the second generation to the third generation of the pill. And that's a factor of 1.67, which you could round up to 2. So while these two headlines may be mathematically equivalent, one of them doesn't really seem newsworthy, does it? And the other one is very clickable and shareable. And indeed, this headline caused a panic and drove thousands of women to switch their birth control pills, and this led to a rise in unplanned pregnancies and abortions when they had previously been falling. You can't consume news just by reading the headlines, because lots of them are phrased in a way to be intentionally provocative, and the numbers might not mean what you think they mean.
A lot of good lessons in there. Don't disagree with any of that. That was tremendous. So, headlines of a study say a certain type of birth control doubles your risk of blood clots. But what does that risk actually mean? What is the absolute difference? And the absolute difference is actually quite small. And the reporting in this case had a real impact as people ran away from that birth control, and that led to a rise in abortions, even though arguably that wasn't necessary because the risk difference just wasn't that big. Here's another example from The Simpsons, the episode Homer the Vigilante. So after a burglary, after his daughter Lisa's saxophone was stolen, Homer starts a posse to deal with crime in Springfield. And we get this exchange between him and Kent Brockman, the news anchor. Kent says, Mr. Simpson, how do you respond to the charge that petty vandalism, such as graffiti, is down 80%, while heavy sack beatings are up a shocking 900%? And well, what do you say to the accusation that your group has been causing more crimes than it's preventing? So my question to you is overall crime in Springfield up or down? Do you know? And if you don't know, what do you need to know beyond that you've already been told? And I want you to pause the video here. And again, don't read your classmates' responses yet until you write one. Just respond to the comment I've placed. Take a few seconds. All right. Another point is you want to be extra careful with proportions that are right around 0% or 100%. This is somewhere that absolute versus relative differences and just how you frame a question makes a huge difference. So for example, you could express confidence in two different but equivalent ways. You could say one model is 97% sure somebody's going to win an election, and another person is 99% sure somebody will win an election. The relative difference there, 99% divided by 97%, is tiny. And that may seem like people are in agreement. But flip that on its head. One model is 3% or thinks a candidate has a 3% chance of winning, and the other thinks the candidate only has a 1% chance of winning. Relatively, one model is 3 times as bullish on a candidate as another. So which one of these is right? What's the way that you want to think about it? Or you want to communicate this? Which feels like a bigger difference? There's a huge difference in how people are going to take this, depending on whether you report it as 3% versus 1% or 97% versus 99%. And you have to be on guard for both how you communicate this and how other people try to communicate it to you. Nate brings up an even more egregious point, I think, when he says, I don't agree with the idea that an 89% forecast and a 72% forecast are close. They both agree that one candidate is more likely to win than another, but there's quite a substantial difference, actually. And it's easier if you flip those on their head. And instead of comparing 72 with 89, you compare 11 with 28. I think that just that framing makes a huge difference in how people think about that. So be aware. One common manifestation of this problem is percentage points versus percent differences. This is another thing you need to be on the lookout for, especially when dealing with proportions. A percentage point difference would be like saying 20% minus 10%, and then saying the exposed group is 10 percentage points more likely to die from heart disease. But you may also see somebody create a relative measure and calculate a percent difference, which would be 20% divided by 10%, and they'll say the exposed group is 100% more likely to die from heart disease because their risk is doubled. Although sometimes you'll see people write something like 200% more likely to mean doubling, but actually 200% above and beyond the baseline risk in the unexposed, in my opinion, implies tripling, because you're going from 100% to 300% risk. So I like to use slightly more cumbersome but clearer phrasing of the exposed will have 200% of the risk of the unexposed. So just be careful with that. If we have our smaller gap in lung cancer death, 2% versus 1%, you could say the exposed group is 1 percentage point more likely to die from heart disease. But you could also say the exposed group is 100% more likely to die from lung cancer. These should say lung cancer, not heart disease. My apologies. Here's a hypothetical example of reporting on a country's GDP. So one country's rose 1% and another's rose 0.1%. So one thing we could say is the growth in country B is 0.9 percentage points higher than in country A. Okay, it's accurate, doesn't sound very exciting. Or we could say growth in country B is 1,000% that of country A. Whoa, that's wild. Much more intriguing. But consider what happens if country A's GDP growth drops to just 0.001% instead of 0.1%. Now country B is 10,000 times the growth rate of country A. even though there hasn't been that big a drop in country A's GDP. So this raises a broader issue of, I think it's always really illustrative to try making tiny tweaks to your numbers and see if whatever interpretation or statistic that you're presenting changes dramatically. If that statistic that you're presenting changes dramatically to just small little changes in the data, rethink how you're presenting it. All right, that's it for this video. When we come back, we're going to close out talking about denominators and misleading visualizations. See you soon.